In this presentation, I'm going to demonstrate the use of a couple interactive tools we've been developing. Though definitely distinct, both are designed to help contend with different aspects of the challenges one faces when researching the anatomy of the brain's white matter. Of course, I should note that both of these are works in progress, and we're hoping to engage others to collaborate should there be interest. Even so, we feel that these tools can be of use to researchers in their current developmental states. Both of these tools take the form of Jupyter notebooks, meaning that they are interactive code documents featuring both sections of code and textual explanations of how the logic of the methods being used are progressing. Thus, if a user wishes, they can download the corresponding repository from GitHub and then replicate the same functionalities you're about to see locally. The use of Jupyter notebooks also allows users to make use of mybinder.org to run these same notebooks virtually in their browser, with some limitations as noted by the notebook itself. Now, why did we develop these tools? Many investigators studying white matter have recently noted that there are extensive challenges to investigating this tissue. These challenges include, but certainly aren't limited to, the complexity of software used to interact with diffusion-derived tractography, and the disorganized state of the literature on white matter anatomy itself. Let's see how these interactive tools can be of use for these challenges. The first tool is an interactive segmentation resource for use within the browser. In many cases, the full software architectures for exploring tractography are complicated and difficult to set up. Here, we provide a streamlined resource. We begin with our most basic tool for this, which starts by requesting users point to 4 different data objects that will be needed. These are a reference atlas, reference anatomy, a lookup table for the reference atlas, and the tractogram itself. Along the way, users are encouraged to inspect these products, both as a matter of quality assurance and to help contextualize their exploration. The atlas is then used to perform a whole brain segmentation. And from this, by specifying regions of interest from a table, users can then view those streamlines that terminate in the selected areas. Here we're looking at connections between subsections of the frontal and temporal lobes. The information garnered from this inspection can then be used to develop insights about the data itself, particular connections, or the broader characteristics of the white matter. More advanced forms of this tool are also available, which afford more advanced segmentation capabilities. These include the specification of spherical inclusion regions of interest anywhere in the brain, or the application of a sequence of both planar and spherical segmentation criteria. But how do you know what you're looking for? What sorts of information is already out there about these white matter structures? In order to help address these sorts of questions, we've developed a curated database of information derived from research articles discussing white matter. This information includes standard publication metadata, as well as records of which structures are discussed, where in the documents those structures are discussed, and which figures are associated with those structures. Moreover, we provide an interactive framework that allows users to explore this database right in their browser. After selecting from a table which structures the user is interested in, the interactive resource can then be used to produce the precise textual descriptions associated with those structures. Here we've selected articles with descriptions or depictions of the arcuate fasciculus. An individual user's ability to access this information is partially dependent on the access rights afforded by their local IP address. In some cases, journals may require users to utilize an IP address associated with a university, or may forbid access altogether. This is an aspect we're working to improve. In a similar fashion, users can also view figures of these same white matter structures of interest. With these tools, we hope that we can facilitate other researchers as they explore the white matter of the brain. These resources are under continual development, with constant improvements to user interfaces, accessibility, and content. Additionally, the actual curated data structure underlying the white matter anatomy database is growing every day due to the diligent work of our research assistants, and likely stands as a valuable resource for potential follow-up work. Should you have any interest in helping to build these resources or extend them, we encourage you to check out the corresponding GitHub repositories or to message us directly. Thank you for your time and attention.